Hello learners, welcome to Little Atoms. Today we are going to understand the topic atomic radius, periodic classification of elements. Objective of today's class: define atomic radius and explain how it is measured. Differentiate between covalent radius, metallic radius and van der Waals radius. Explain how atomic radius varies across a period and down the group in a periodic. We know matter is made of indivisible particles called atom, according to Dalton atomic theory. Assuming atom is indivisible, how big an atom actually is? We cannot see atoms even under the most powerful microscope. So, how do we know atomic radius? Although knowing the radius of an atom helps us know chemical reactivity and chemical bonding, it is so small, even with electron microscope we cannot see a single atom. Atomic size is 0.1 nanometer and visible light is 400 to 700. To see an object, light must bounce off from the object and reach our eyes. Since atom is too small, light cannot bounce off from it. Scientists don't actually take a real photo of an atom instant. They map its structure using beam of electrons. A very thin sample is used and kept under cryogenic, very cold conditions so that it does not get damaged by the electrons. When the electron beam hits sample, most of the electrons pass through while some are scattered. This electron fall on a fluorescent screen or detector, creating bright and dark spots. From these patterns, computers reconstruct or map the position of atoms. So what we see is not a real photograph but a scientifically created image based on the electron data. Imagine your room is completely dark and there object in front of you but you can see it. So you throw tiny rubber balls. Most of the balls pass without hitting but few bounce back. You can guess the shape now. Yes. Atomic radius. How big an atom is? In a simple word, it is distance from the center of the nucleus where protons and neutrons are to the outermost electron of that atom. Since there is no well-defined boundary for an atom, we can measure atomic radius by taking half of the internuclear distance in a homoatomic molecule. Homo means same. Internuclear distance is also known as bond length. Types of bond, based on that we'll have different types of radius. So chemical bond are of four types: covalent bond, ionic bond which will give ionic radius, metallic bond, metallic radius, van der Waals radius. Covalent radius is half of the distance between the nuclei of two atoms that are bonded together by a single covalent bond. Example: two chlorine nuclear atoms form a Cl-Cl. Bond distance between is 198 pm. Covalent radius is 192 divided by 299 pm. Picometer. How to find covalent radius by experimental technique? X-ray diffraction or electron diffraction. Divide the bond length by 2. If it is heteronucleus, that is different, then radius of A-B bond length will be radius of A plus B. Covalent radius depend on the bond order. Single bond will be greater, double bond then triple bond. Covalent radius decreases across period from left to right in the periodic table due to increase in nuclear charge, positive charge, or the number of protons. Increases down a group due to among the following which has the smallest covalent radius: fluorine, chlorine, bromine, iodine. Covalent radius increases down the group in halogen: fluorine less than chlorine less than bromine less than iodine. The bond length of the HCl is 127 pm and the covalent radius is of hydrogen is 37 pm. Find the covalent radius of Cl. Bond length equal to radius of H and radius of Cl. Ionic radius. We know covalent bond is formed by sharing of electrons, example Cl2, but in case of ionic bond, it is formed by transferring electrons, means either losing or gaining of electron. If we lose electron, cation is formed, positive charge, cation, trick to remember. Example sodium. Similarly, anion, negative ion, gaining of electron by an atom. Example, Na gives 1 electron to Cl and Na becomes Na positive and Cl becomes Cl negative. Now, in anion, the ion expands. So, anionic radius greater than atomic radius. But cation 1 electron is lost, ion very small, so cation less than atomic radius. So anion greater than atomic radius and cationic radius. We can say ionic radius is distance from the nucleus of an ion to outermost shell of electrons. Example sodium chloride. Distance if 2.82 angstrom, then we can find out the radius of Na positive. Ionic radius inversely proportional to the charge. Metallic radius. In metals, atoms are closely packed in layers around positive metal ions. Electrons move freely. It is called electron C model. Definition: metallic radius is half the distance between the nuclei of two adjacent metal atoms that are bonded together by metallic bond in a crystal lattice. Metallic radius half the distance between center of two adjacent metal atoms. Example, in crystals of sodium, distance between the nucleus equal to 3.72 angstrom, then metallic radius half into 3.2, 1.86 angstrom. Van der Waals radius. How close can one atom get to another atom if they are not chemically bonded? If two atoms not bonded, they cannot get too close because their electron cloud repel each other. Take neon, noble gas. Neon are not bonded. They just touch and do not overlap. So Van der Waals radius is half the distance between the centers of the two atoms that are just barely touching each other. Due to this repulsion, Van der Waals radius if 154, then covalent radius will be less. So today we learned atomic radius, ionic, covalent, metallic and Van der Waals radius with examples. Next video we will solve problems on ionic and atomic radius.